This is Geometry, Chapter 14. We're going to start with Lesson 1. Okay, so we're going to have a new name for a line that we learned in the previous chapter. All right, remember what we said about what is cyclical, or what is cyclic. What is cyclic? What types of polygons are cyclic?
Quadrilaterals that have supplementary opposite angles and triangles.
That's right. Every triangle and quadrilaterals whose opposite angles are supplementary. And there's one more. Any regular polygon. So what makes a polygon regular? Equiangular and equilateral. That's right. Any polygon that is equilateral and equiangular is called regular. All right? So that's lesson 1, regular polygons. No. That's almost all of it. So a regular polygon is not just equilateral and equiangular, it is also convex. What is convex? Yes.
It means you can put 2 points anywhere inside the polygon and you can draw a line between them and it won't intersect any of the sides.
Right, and it doesn't go outside the polygon. That's right. So really it doesn't cave in on itself. But that's the math definition you gave. I can connect any 2 points inside the polygon with a line segment, and that line segment will never exit the polygon. It will never go outside the polygon. That is what a regular polygon is. All right, so look, we have polygons on page 573. We have an equilateral triangle. We have a square. We have a regular pentagon. Pentagon has 5 sides. Hexagon has 6 sides. Heptagon has
7,
octagon,
8,
nonagon,
9,
decagon,
10,
dodecagon, 12. Excellent.
Yeah.
12. Okay. And what the statement that I just made about regular polygons being cyclic is your theorem 70 for every regular polygon is cyclic. Okay, so now I want to go back. I'm going to try to draw a regular pentagon. That's pretty decent. Pretty decent. Okay, let's say that is a regular pentagon. Equiangular, equilateral. All right. How would I construct a circumcircle? How would I construct a circumcircle? Isaac and Therese know. Who else? Jesse. Actually, the other son, Jesse. It's Hij. Yes, Hannah. Around it, a circle around it.
Oh, you perpendicular
Bisectors of the sides. That's right. So I do perpendicular bisectors. So I have a circle, right? That I am circumscribing. What is the radius from the circumcenter to a vertex? That's called a radius. That was easy, wasn't it? Okay. Now, when I inscribe a circle, I'm just going to inscribe a circle. If I were to inscribe a circle, it would look like this, right? Maybe. And then its radius would be from the center of the circle perpendicular, right, to the side. Yep.
Can you just use that to construct the circle? And you can just set your compass to the radius and draw?
Well, we're actually not going to do constructions here, but yes, to construct your circle, you set your compass to the radius and go all the way around. Yes. And we called this the radius of the end circle, didn't we? Now we're going to call this, in terms of the polygon, God bless you, in terms of the polygon, so now we're going to erase those circles. And in terms of the polygon, that is called an apothem, which is on your next page. It's an apothem. Okay? So really, the apothem is from the center of that polygon perpendicular to any side, such that, I'm going to redraw my pentagon so that we just see. This is going to be called the radius. I'm just going to write R for radius. And perpendicular to the side is going to be called your apothem. There's a couple of things that we will need to know. Well, let's read the definition of the apothem. So an apothem is a perpendicular line segment from its center to one of its sides. It's really that concept of being the end circle and finding the radius of the end circle, all right? All right, notice that if I were to do this, I would have two radii with the apothem in the middle. And it not only bisects the side, but it bisects that angle. Yes.
So it's not like the circles, the radius is to the segment that's tangent to it?
The radius is to the vertex, so it's the circle when you're thinking radius. The apothem is just like the radius of the end circle, but now we're going to call it an apothem because we're not talking about the circle, we're talking about the polygon. Right. All right, and so that we're going to use the radius and the apothem to calculate area, to calculate perimeter. We're going to use these concepts in the next two lessons to calculate our area and our, even the length of a side, we could use it to calculate. So this becomes a right triangle. So I want you to think outside the box. I want you to think trig. Okay? Think trig. Yes, anytime you have a right triangle. Okay, now, can we know, it's a pentagon. Can we know what each angle in this pentagon is? Yes.
Okay, we do know the opposite base. I think the ones to the right and the left are equal because the radii are equal.
Okay, like this angle. Could you calculate that angle? How? Yeah.
Don't you divide 360 by the number of angles?
No. So a triangle has 180 degrees. A quadrilateral, four sides, has 360. But there's a formula that I gave y'all that you haven't used at all to figure out. And it's 180 times n, that means the number of sides, minus 2. Okay, so like three-sided is a triangle. What's the sum of the angles in a triangle? 180 times 1. A four-sided quadrilateral, 4 minus 2 is 2. 2 times 180. 360. Okay, now we have a pentagon. It's a five-sided. 5 minus 2, 3. 3 times 180. 3 times 180. You jumped to 540. That's right. You jumped one. So all of the angles would add up to be 540. But one of the angles would be 540 divided by 5 angles. So what is that? 108. Each one will be 108 degrees. Okay? That's the formula. And remember we talked about external angles. Okay? And you could have looked at what the internal angle is by looking at external angles. If I add all of the external angles, what's the sum of those angles? The sum of all of the external angles, do you remember external? An exterior angle is one that is a linear pair to the one inside.
So they'll make.
So the sum of these angles on the same side, it doesn't matter how many sides you have. They will always equal 360. It doesn't matter if you have a pentagon, an octagon, a dodecagon. The sum of those exterior angles is going to be 360. So what we have 5. So 360, what's 360 divided by 5? 72. So this one would be 72 degrees. It is a linear pair with the internal angle. So if you forget this formula, don't ever forget that the sum of those external angles is 360, because you can always get what the internal angle is if it's regular. This only works if it's regular polygon. Okay?